Okay, so this is Centroids of Composites, and now this time we're looking at this shape, okay? So let's switch over to our presentation here so you can see, okay? Um, this works the same way, except we're going to assume that the plate is homogeneous. It's the same all the way through. So that makes the weight proportional to the area. So we can just use x bar is equal to the sum of the little areas times the x divided by the total area. Same is true for y. Alright? So if we're looking at a composite shape, alright, and we are just going to use multiple shapes to describe a simple shape. Alright, there are three areas we could use to describe this shape. This big outside rectangle, okay, this circle, and this empty rectangle here. Okay, so what do we do when we're talking about um, this? We are trying to find the centroidal axis. Okay, so this would be our reference y-axis, okay, or our x coordinate system, and this would be the reference for our x points, okay, which really just says we're pick the origin where it's convenient, and I'm going to put it there, okay. So we put the thing here, okay, and how do we handle these missing areas here and here? We just make them negative areas, alright. Now, we could have done this one with three other shapes, this little rectangle here, this large rectangle, and then the circle, okay? So you'd have two positive and one negative. It doesn't matter, both ways will yield the same result. So let's go on and work this example. But I find that I like to make tables, so today I'm just going to make the table in Excel so it's easy for you to see. Okay, I'm going to take the large rectangle, okay, to be my overall shape 1, alright? And so the area is going to be equal to 6 times 6. Alright, and the x of that, if I put the origin here, the x would be halfway through the 6 inches, that'd be 3, right? Okay, y is also going to be 3. So this is going to be equal to this times the area times the x, okay? So it's going to be equal to the 36 times the 3. Alright, let's do it that way. Equals, I'll type those numbers in for you. 36 times 3. Alright, and this one is going to be equal to 36 times 3. Alright, so now let's do this missing rectangle, and it's negative area, so it's going to be equal to a negative, and it is 2 inches tall by 4 inches long. 2 times 4, okay, and the x of that would be in the center of the rectangle, okay. So I'd have to move the 2 inches to get to the beginning of the rectangle, and then I have to move halfway through there. So it's going to be 4 inches. 2 plus, oops, what's that thing here? Equals 2 plus 2. Alright, so this is going to be equal to negative 8 times 4. Right, the y is just going to be from the bottom 1 inch up. Okay, so because it starts at that y equals 0 point. Alright, so it's going to be equal to 1 times, so that's just going to be equal to 1. And this one's going to be equal to 1 times negative 8. Okay, then for the circle, it's going to be equal to pi r squared, so that's going to be 3.14 times 1 squared. Okay, the x location of that is 3.5 inches. So this is going to be equal to 3.14 times 3.5. Okay, the y is going to be 2 inches from the top, so that's 6 minus 2, it's 4 inches. And this is going to be equal to 4 times negative 3.14. Okay, I forgot my negative sign earlier. So I'll put the negative in. Okay. So that changes this number to be negative as well. Okay. And then I add these up. Then I need to add the AX's up. And then I need to add the AY's up. Okay. So if I want to find X bar, okay, that's going to be equal to the 65.01 divided by the 24.86, right? And that's going to be 2.62 inches, right? And Y bar is going to be equal to 87.44 divided by 24.86, okay? And you can see that Y bar is 3.52 inches. Right? Let's look at our problem here. Does that make sense? Yeah, it actually kind of does seem to, because there's a lot of stuff missing down here, a negative area. Okay, so it's over here in the X, so it's going to be less than halfway. There's more of the plate on this side than there is on this half of the plate. Y bar, the same is true. There's a bunch missing down here, so it's going to be above halfway. Alright, so I hope that makes sense to you. Let's go back now and look at the next example. Alright, so then we have this more complicated shape. Alright, you can find the formulas for where to locate the centroids in the inside cover of your textbook. It has both the formulas for area, volume, and the location of the centroid. Alright? So I'm going to go get a table set up, and then I'll be right back with you.